Today's topic of discussion is Huffman's algorithm, Huffman's tree creation, Huffman's coding. So prior to this, we have discussed in a video, which is the part one of Huffman algorithm, prerequisites of Huffman algorithm. That is, what is two tree, what is extended binary tree, what is path length, what is external path length, internal path length, what are internal node, what are external node, what is weighted path length. So we have discussed all those things. So if you're directly coming to this video, I request you to kindly watch the first part of Huffman's algorithm video so that this video become easy for you to understand the topics of what we are going to discuss in this video. So let's start with Huffman's algorithm. So Huffman algorithm in front of you. So Huffman algorithm, as I've already told in first video, this Huffman algorithm is used for data compression. This is used for data compression. Why data compression? Suppose you have a letter having no suppose you have a word file of 10,000 words. Now you want to compress this file. So because there are few words, a, e, I, o, these words are very frequent. These out of 10,000 words, these words are around 200 500 words of characters which are used. So we need to assign a smaller code to these characters. And suppose Z and X are character which came very rare, so we can assign a little bit greater code to them. So in that case, we can by doing this, we can compress our letter, we can compress our word file, or we can compress our anything. No, so this is with the help of how we can achieve this. We can achieve due to because of Huffman's algorithm. So the idea is to assign a variable length code. The idea is to assign variable length code to whom? To input character. This is what I gave you, to input character. Length of assigned code, and these length of assigned code are based on frequency. So the length, I told you, length depend on frequency, how many time a character is appearing of corresponding character. The most frequent character, these characters get the smallest code, I told you, and the least frequent character get the largest code. Fine. So this is what I told you, how we can compress. Now there are two methods, there are two parts, there are mainly two major parts in Huffman coding. Now you have to give a code. No, so in order to give a code, first of all you have to build a tree. So you have to build a Huffman tree. Huffman tree means two tree and extended binary tree. So we have already discussed in part one. So now you have to create Huffman tree for input characters, and then you have to traverse Huffman tree and assign a code. First of all, create tree and then assign a codes. Fine. So let's start with Huffman algorithm. So what algorithm is all about? See this algorithm. What algorithm is saying, suppose W1 and W2 are minimum weight among n given weights. W1, W2 and Wn. Suppose you have weights 10, 2, 11, 5, 19. Now you choose two minimum weights. This one is W and this one is W2, and add them. So now remaining weight will be n minus 1. So you added, when you added these two weights, so remaining weight will be what? N minus 1. Why n minus 1? Because when you add this, this will become 1, and this is n minus 2 weights, so n minus 2 and 1, n minus 1 weights. Fine. So find the tree T dash which gives the solution for n minus 1 weights. That is W1 plus W2. One weight will be this, and remaining n minus 2 weights, this will be n minus total n minus 1 weights. Then in tree T dash, in the tree you have created, replace the external node. Now you have to replace the external node W1 plus W2. When you add, you will have to replace by subtree D. You have to make a tree something like that. So if you're not getting here, we'll discuss just after this, we'll discuss a question, so you will understand what we are talking about. The new two tree is desired solution. So we'll after doing all this multiple times, we'll get a new tree, that is two tree will be the desired solution. So let's understand this by solving a question. So let's see a question. So here you have a question. Suppose A, B, C, D, E, and F, G, H are 8 data items, that is 8 characters in a letter, you can say. And suppose they are assigned a weight as follows, that A has 22. Suppose A has appeared in a letter 22 times, B only 5 times, C 11 times, D 9 times, E 2 times, F 11 times, G 25 times, and H 5 times. Now what you have to do, you have to know your main task is coding. But what are two steps? First tree, then coding. Then what is the method? Select two minimum weight, select two minimum weight. So let's select two minimum weight, and then Let's select two minimum weight and then start the question. So we have these weights. What are two minimum weights? So one minimum weight is E, and then the second minimum is either B5 or G20. Sorry, B5, or it could be we have a H5. So one this one is fixed. Now you have to choose among these two. You can choose any. You can choose any. Whatever you want, you can choose. There will be no issue. Suppose you choose this and this. So when you choose this and this, what will happen? So you have A22, you write this A22. When you choose this, so 5 and 2 will become 7, you write 7. Fine. Here you have written B5, and here you have written E2. Anything can go anywhere. B5 can be on right side, E2 can be on left side, anything go anywhere. Fine. Then you are left with C11, then you left with D19, then you left with you consumed E2, then you left with F11, then you left with G25 and H5. Fine. So these are n minus weights now, na? Because 7 is also part of this competition. No, you have to choose. When you are choosing now two minimum weight, then 7 will also be included. Now because of this has become n minus 1, because previously there were 8 data item. Now there are 1 2 3 4 5 6 7. So now this has become n minus 1. Again you will select two weight. So this will keep on going for n minus 1, n minus 1, n minus 1. Fine. Okay. Now you select two minimum weights. Now what are two minimum weight? You have 22, 7, 11, 19. So two minimum weight will be, one is 5 and one is 7. So I'm making a tree now. So when you add this, so the moment you add this, it will become A22 will remain like this. 5 and 7 will become 12, and this will have H5. This will have 7. Right side will have 7. Then B5 you have, and then you have E2. Fine. And remaining are C11 and D19 and F11 and G25. Now you have 6 remaining weights. Fine. Now again you have to choose two minimum weight. What are two minimum weight? These are two minimum weights, C and D. C and D are two minimum weights now. Sorry, C and F are two minimum weights, 11 and 11. So when you add them, so I'm making over here only. So when you add them, let D19 come here. So D19 is the remaining. So when you add them, you get what? 22, right? And you can use anything anywhere. Suppose C11 come here and F11 come here. So now you are left with only 5 bits: 1, 22, 112, 19, 22 and 25. Now again you have to select two minimum weights. What are those two minimum weights? Now 12 is one minimum weight and 19 is second minimum weight. So when you add this, what you get? A22 will remain like that. 12 and 19, when you add 12 and 19, you get what? 31, if I'm not wrong. Yes, 31. 31 you get. Then here you have 12, then you have H5, then at right of 12 you have 7, and then you have P5, and then you have E2. Fine. Then you have E2. And at 31 right, suppose you are writing D19. D19. So now you have consumed the two weights. Which two weights? 19 and 12. Now you are left with A22, this 22 and a C11, uh, having F11, and the last you have G25. You are left with four weights. Fine. Now you have to select two minimum. What are two minimum? 22 and 22. 22 and 22 are two minimum. Fine. So when 22 and 22 are two minimum, you add them. The moment you add them, what will happen? So suppose I'm writing G25 here, huh? And I'm adding those 22 and 22. The moment you add 22 and 22, what will happen? It will become 44. So 44. Suppose I'm using A22 here, then 22 will come here, and this 22 here, and then you have C11, and then you have F11. Fine. So now you left with three weights, that is G25, 31 and 44. Now two minimum weights. What are two minimum weights now? 25 and 31. 25 and 31 are 25 and 31 are two minimum weights. So this and this will get selected. So finally what will happen? If I make a tree, then what will happen? 31 and 25, the moment you add, you get 56. You get 56. Fine. So you have G25, suppose this side. Now you have 31 here. Then you have D19. Fine. Then you have 12. After that you have H5. Then at right of 12 you have 7. Then 7 left you have B5. And 7 right you have E2. Fine. And this is one tree after adding G25 and 31, and you have still one more weight which is 44, then A22, and then 22, then you have C11, and then F11. Again you have to choose two minimum weight. Now you have no option, you have only two weights. Now you add this. The moment you add this, what you will get? You will get 100. Fine, you get 100. So let me make it little bit upper. So you get 100. So now left of 100 I'm using 44. So 44 left you have A22. 44 right you have 22. Then 22 left you have C11. And 22 right you have F11. Fine. Then you have 56. Let me make it little more far from this place. 56. 56, then you have G25, and at right you have 31. 31 right you have D19. 31 left you have 12. Then you have H5, and then you have 7, and then B5, and then you have E2. Fine. So this is now your final. This is now your final Huffman tree. So first part of algorithm, first part of coding is you have to create a tree. You have created a extended binary tree or two tree where each node, circle, is internal node, and each square node or rectangular node is external node. And so you can see that it's a two tree, that no node is having one child, every node is having two child. Fine. So this is a tree. So now you have a tree like this. So the final tree is something like this, which you have created. Now you have to code. So what is Huffman's coding? Now what you do, assign to every left 0, every node left 0, and right 1. Suppose this is node left 0, right 1, 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 left 0, right 1. Now suppose you want to calculate the code of A. So start from root. So when you reach to root from the moment you reach from root to A, the code will be 0 0. So code of A will be 0 0. Now code of, suppose you want to find the code of G. So the code of G will be again 1 1. G will be 1 1. Suppose you want to find the code of F. So F will be 0 1 and 0. So F code will be 0 1 0. Now suppose you want to find E code. So E code will be, how you can reach E. You start from this, then you come here, then you come here and here. Finally, what the path of E is? 1 0, then 0, then 1 and 1. So you have seen the nodes which are having highest frequencies, the nodes which are having highest frequencies are getting low codes, code of a smaller length, and the node which are having higher less frequency, those who are appearing less number of times in a letter, they are getting higher length of code is higher. Fine. So this is what compression technique is all about. Hope now you have understood the concept of Huffman's coding, what Huffman's coding is all about. So hope you are getting that this compression, how we are compressing any kind of letter or something, how we are compressing by giving a small code to the character having high frequency and little bit large code to the character having a small frequency. Fine.